Hello class, welcome to lecture 18. We will talk about decisions and p-values. I'm your instructor, Ms. Laura Lowe. We are in the second lecture from week 7. In module 7, we talk about distribution, decision, and A/B testing. From the previous lecture, we're comparing distribution, and also we give you a couple examples about the hypothesis testing. In today's lecture, we will talk about one more example, but this example is comparing the numerical data. Sometimes on your visualization, when we do the hypothesis testing, the result may be not so clear to make the decision. So that's today we will show you the example how we will solve the problem. In the next lecture, we will talk about the A/B testing. Let's do a quick review about the hypothesis testing we talked about in the previous lecture. So we give you a couple examples about testing hypothesis. So the hypothesis is a test choose between exactly two views about how the data was generated. So we call each view is a hypothesis. The test will pick the hypothesis is better supported by the observed data. So the most important thing when we start doing the hypothesis testing, we will have two different points of view. So then we will see our simulation, which view we will support or more favorable about. From our two examples in the previous lecture, basically we are doing the null and alternative hypothesis. So this method only works if we can simulate data under one of the hypotheses. So basically we will have usually we have a model that's a chance model. You have many assumptions on that. So we use that as a null hypothesis. So you can see the null hypothesis have a well-defined chance model about how the data were generated. So we can simulate data under the assumption of the model. So that's why assumption we need to follow all the assumptions to do the simulation. So that's we say is under the null hypothesis. So then we have another hypothesis we call is alternative hypothesis. That will be a different view from the model itself. So on the other hand, the other point of view kind of against the model we created earlier. So that's why when after we do the simulation, then we will compare our results from the simulated data and the observed data. As you remember, you have this null and alternative viewpoint. So after you understand that, we need to choose a statistic. So this statistic is we choose can use that to simulate. We will simulate our model, then to find the statistic. So we can make the decision between the two hypotheses. So that we call the statistic we choose is the test statistic. Choosing this statistic is really important. So before we choose that, we may need to review again. So that's the question you should ask before you choose the statistic. So we have different statistics. So which statistic value will help us see the simulation and lean toward to the null hypothesis? Or what value will make us lean toward to the alternative? So that's we'll need to make sure when we want to find the statistic when we simulate the model. Okay, so this value is also can compare with our observed data. So after we simulate that, so when we want to decide they are lean toward to the null hypothesis or alternative hypothesis, we need to see the observed data. So what the value will make the decision. So preferably, we need to see when we compare the observed data and your simulation result, the answer should be just high. or we say just low. Okay, we want to have that only link to one direction only. If you have your observed data kind of possibly toward to both direction, then we need to try to avoid that. For example, remember we will, if they have either too low or too high, then we can just try to find maybe the distance from our hypothesis. So you need to avoid, you will check both direction. We want to have just one direction to check our data, compare our observed data and our simulation. So prediction under the null hypothesis, that's earlier we say we do the simulation, that's mean the prediction. So under our chance model, we can do the simulation to test the statistic under the null hypothesis. So after you simulate with a large amount of time, then we can draw the histogram of the simulated output or values. So this result we will display in an empirical distribution of the statistic under the null hypothesis. So remember, empirical distribution is what? Also, actually, all our example we show you earlier, we're using the categorical data. So this categorical data, then we have our result. Then we do the simulation many times. So then we have the empirical distribution. So that's from our simulation. So this is a prediction about the statistic you choose. So under the assumption about the model. So they will show all the simulation result. So if you cover enough, right? So that's why we want you to run many times. So they will have coverage as much as they can. So in the empirical distribution result, they will show all the value from the statistic from the simulation and how they look like. So one thing we need to just remember here, we try to remind you many times. Empirical distribution, when they have under many and big enough simulation times, the distribution will be very close to the probability distribution. But we'll just say close to. Be careful, it's always say close to, because the probability is just approximate. No matter how many times you run, you still cannot cover the whole possibility. That's on the other hand, that's mean even you simulate 10,000 times, 100,000 times, but they still cannot generate all the possible random sample. So we couldn't cover all the population. So after you have your simulation, of course, we need to conclude our testing. What conclusion we will make? Yeah, of course, we want to have the choice. We resolve the choice between the null and alternative hypothesis. You need to only choose one, right? So we see which we will be favored for. We compared observed test statistic and the empirical distribution we simulated. Yeah, the data we simulated, then we draw that in an empirical distribution from under the null hypothesis. So if the observed value is not consistent with the distribution, so most of the time we say it's not consistent, that will be very far away from our simulation result. So if your observed data kind of not covered by our empirical distribution, so then we will favor, the test will favor the alternative. Okay. So that means the data is more consistent with the alternative. So of course, right, so if your observed statistic data is we think actually kind of maybe in the middle or even better in our empirical distribution. So then we will say the observed value is consistent with the distribution. Then we will favor the null hypothesis. Of course, whenever a value is consistent with a distribution, that's because we drew the empirical distribution. That's our visualization. So that's we plot the observed data in that histogram, so then we can compare. So usually, right, so visualization may be sufficient. So if not, so there are conventions about the consistency. So on the other hand, we will show you more example on how we will make the decision. And also the most important example in lecture 18 is, from all the example we showed you earlier, that's categorical data, categorical attribute. So then in the example today, in this video, we will talk about another example that is the numerical attribute. So that's our next example. In this example, we have a big statistics class. In this class, we have few hundred students. So we divided into 12 discussion sections. So the graduate student instructor, the GSI, they lead the sections. So after the midterm, the student in section 3 noticed that their average scores from their section is lower than other section. So that's they observe. Student in section 3, they find that. So then here is our hypothesis. So according to the graduate school instructor's defense is, we call that the null hypothesis. So we pick up each section by random from the whole class. So sometimes, so that's why we could have got an average like this one. So on the other hand, that's me. Our model is we pick by random from to group each section. So what happened from the section 3? They state they think that's lower average, but actually just an average will happen. So that's our null hypothesis. So of course, then we need to have alternative hypothesis that will be against this one, right? So then our alternative is no, the average score is too low. So the randomness is not the only reason for the low scores. Okay, so that's our null hypothesis and alternative hypothesis. So right, we need to do our testing, right? Okay, so then let's go to see the data. Okay, so in our demo file, let's see our new example data. So we have the CSV file. So let's create the table we call scores. So this one, the same thing. The default, we display the first 10 row. So then you can see from the 349 row skip. So then that total, we have almost 360 students in this class. So you can see in this data, we have two columns. The first column means each student section number and their midterm score. So you can see the midterm score definitely is not out of 100. Okay, so let's see how to get each section, each count, the count for each section. Okay, so how we do that? So we can group the section row, right? So we group the section. So we got the table that's grouped according to the column 1, the label name section. So that's how we can see, so we have totally 12 sections. So then from here, you have the number. But one thing is, since section 3, they talk about is their average. So that's find the average. So how to do the average? So then we just display the count. So we don't want to display the count. We want to display also not the midterm score. We want to have the midterm average. So that's why the same thing. You still do the group. So then we just want to the rest of the column to find the average. So let's see the average from all the 12 sections. Okay, so you can see, right? So from the score list, section 3 did have lower average. Okay, so we just want to see this lower average is really too low or not. Okay, so since this one is our observed data, so let's save this value in here. Okay, we have observed average. So now we need to do our simulation to draw our empirical distribution. Okay, so then we will continue in the next lecture, or the next video.